Very much for the warm introduction, and hello everyone. Thank you for having me here. It's actually an honor to be able to speak in front of you as experts who are actually driving CCS forward. Um, as you know, at EU level, we are committed to reach net zero emissions by 2050. Um, This year has actually brought three really important milestones on our way to this. And actually, it is your efforts over the years who have actually helped driving in this direction. In order to reach net zero by 2050, advancement in renewable energy, energy conservation, or energy efficiency are paramount. However, until we manage to reach more stable energy sources, industry needs to be helped into this transition, and industrial carbon management is a very important step in this direction. What was the one of the milestones which I mentioned earlier? In February this year, we have published our 2040 targets. Reach 90% emission reductions compared to the 1990 levels. What is important for industrial carbon management is that the impact assessment of the 2040 targets has actually confirmed the critical role of carbon capture and storage or utilization for reaching this 90% emission reduction target. So according to the modeling results, you see a graph on my slide. For 2040, we need to start capturing 280 million tons per year. And for 2050, we need to start capturing 400 million tons per year. Of this, at least half, actually more than half, will need to be stored. Also for 2030, we have an objective to capture and store at least 50 million tons per year. What we have today, at least at EU level, is EU-funded projects which plan to capture 12 million tons per year starting 2030 and no place to store them. So basically what we need to do is to get from 0 to 50 million tons injection capacity in the next 5 years, and then from 50 to another 200 in 10 years. This is a really challenging road, and what we think that is going to help in this direction is the increasing political support for industrial carbon management, including CCS, at EU and member state level. So in terms of policy developments, some of you already mentioned a part of them. We have the Net Zero Industry Act, which places CCS at the same level as other net zero technologies, such as renewables or batteries. The act was proposed last year by the Commission, and it includes for CCS a CO2 injection capacity objective. Political agreement was reached in February, also when the 2040 climate targets were published, and it should enter into force next month. We also have the industrial carbon management strategy, which is built on the direction of thought brought by the Net Zero Industry Act. It was also published in February, so February this year was an important month for ICM. And it comes with actions that should be implemented by the Commission and European states in order to make ICM reality. What we have at European states level is that 22 EU member states have included industrial carbon management, so CCUS, and carbon removals in their national energy and climate plans. However, of these, only 6 have actually included actual objectives for the capture side or actual mappings of the CO2 capacity, CO2 storage capacity. Then we have 7 EU member states that have included ICM in their recovery and resilience plans. We have 3 European countries that have implemented subsidies for ICM, Denmark, Norway, and Netherlands, and then others are working on this, such as France. And then there are several countries in Europe which are working on their industrial carbon management strategies, such as surprisingly Germany, Austria, and also France. And there is a lot of work going on, both at EU and at every state level, to map the exact capacity that can be put forward for CO2 storage. Actually, before moving to that, in the next minutes, I will be presenting these policy developments at EU level. Then, starting from the framework that these policies bring, I would like to discuss with you the importance of theoretical data mapping. And then I would like to invite you to a moment of reflection on what can actually be done or added to a theoretical capacity mapping so that we can actually transform it into an investment tool useful for investors in developing CO2 storage projects. So the Net Zero Industry Act, its purpose is to help the EU transition to a net zero future. How it is going to do this? By scaling up manufacturing of certain selected technologies and to secure their supply. These technologies include, of course, renewable technologies, energy system related technologies, as well as energy efficiency related technologies. And most importantly for our discussion today, carbon capture, utilization, and storage technologies. It also comes with the objectives. So in order to reach the energy and climate technology deployment needs of the EU, the objective of the Net Zero Industry Act is for 40% of these technologies to be actually produced locally. We also aim to reach 15% of the global production capacity for these technologies. And we also have one deployment target, which is the most important for our discussion today and for your work and our work, which is the 50 million ton injection capacity to be achieved by 2030. There is an entire chapter on carbon capture and storage in the Net Zero Industry Act. And here I tried to summarize all the articles that mention CCS. In principle, what's important to have in mind is that CCS projects, as well as other net zero manufacturing technologies, will have permitting facilities. There is also the objective that I have mentioned before, and it comes with an obligation attached for oil and gas companies to put forward their knowledge and financial resources to make it achievable. Then, as Kerry also mentioned, and this will actually be the core of our discussion today, there is this obligation for member states to release and make transparent geological data, but not only geological data, also project-related data and regulatory-related data for CCS, which should help investments happen. Then there are also provisions to incentivize the deployment of CO2 transport capacities and infrastructure. And considering that all these provisions will most probably bring big impact into the industrial carbon management market, there are also obligations for both the Commission and the member states to monitor and report on how the market will. The centerpiece of the CCS chapter in NZIA is the CO2 injection capacity objective. It comes with two important conditions. First, no enhanced oil recovery projects are allowed to contribute to this objective, and also all the projects that, all the storage sites that would contribute to the achievement of this objective will need to be operational for at least 5 years. Why is that? It's because we want to see commitment from the part of investors, and we want investors who actually develop storage sites to start shaping a new business, moving away from the development of fossil energy sources. Based on how things will be going, by 2028, the Commission might also propose a new objective for 2040 or earlier. As mentioned before, in order to achieve this annual injection capacity objective, the Net Zero Industry Act comes with an obligation for oil and gas companies to invest in the development of storage sites by either developing them in their own assets or by investing in other projects developed by other CO2 storage developers. However, this will not make the object of our discussion today. Another important part of the Net Zero Industry Act is the facilitation of permitting. 6 years to develop 50 million tons annual injection capacity is a very short period, as you all know probably better than me. There can be a lot of challenges coming on the way. We want to make sure that permitting will not be one of them. So, NZIA comes with this possibility of member states to recognize net zero strategic projects in all the range of manufacturing technologies proposed. For CCUS, there is this new term of CO2 hubs, which involve all parts of the value chain, so both capture, transport, and storage. For any of these parts of the value chain, the permitting cannot take more than 18 months from the submission of the permit application. This has been designed mainly for countries where there is a one-stop shop for permitting. However, where there is not, authorities will need to coordinate so that this timeline will not be exceeded. When a project will be recognized as a net zero strategic project by a member state, it will also reach the highest national significance, having an overriding public interest. This means that land access will also be facilitated, because having an overriding public interest, land access can be achieved easier for expropriation or other means. At the same time, for potential dispute resolutions, everything will be treated as urgent in line with national law. Okay. And now the most important part, in order for CCS to happen, in order for CO2 storage projects to happen, access to data is essential. This is why NZIA comes with an obligation for member states to make publicly available all data related to potential CO2 storage sites. This reporting should be at least in line with those required by national energy and climate plans reporting. And also member states will need to oblige oil and gas title holders to make public all the data related to hydrocarbon fields relinquished or under relinquishment. What is important to know is that the time frame, so within 6 months, member states will need to design regulations and to explain in what type of data and what format of data will be released. And the actual data release will happen starting with next year, after these regulations will be in place. Apart from geological data, member states will also need to publish annually, starting with next year, reports on capture, transport, and storage projects under development and their status, what national support measures they have in place, what is the transport capacity planning, and also efforts related to cross-border transportation. Building on NZIA, so basically completing NZIA, the Commission has published the Industrial Carbon Management Strategy this year, also in February, as mentioned. It comes with, so NZIA comes with obligations, all sorts of obligations for both operators and member states. The Industrial Carbon Management Strategy comes with operational and enabling conditions in the form of action points. The ICM strategy focuses on three main technological pathways. One is CCS, which we will discuss in more detail after this slide. Then we have carbon removals, so basically BECCS that Rachel was talking about yesterday, and DACs, where biogenic or atmospheric CO2 are meant for storage. For this, the Commission is planning to propose targets, objectives, to include them in the emission accounting system, and or to create a new emission accounting system for this kind of removals. And then a lot of investment is proposed for research because the technological readiness level is very low. Then we have CCU. For this, the Commission has in mind to incentivize the uptake of carbon as a resource and to integrate certain CCU applications in the emissions trading system. The key enabler for all this will be transport infrastructure. As you all know, it might seem easy to develop a storage site or to build a capture facility, but if they are not close by, it's quite difficult to keep it going. So for this, the Commission is planning to build a network planning mechanism, to build a regulatory framework for CO2 transport, to work on CO2 standards, and also to propose guidelines for maritime transport. Before moving to the CCS part of the ICM strategy, it's also interesting to mention that there are also enabling environments which the Commission has in mind. So there will be new investments, new funding opportunities to help investments. There will be a lot of work done on public awareness, and actually, you were talking about this yesterday, and I think one of the most important works that will be done under public awareness, the Commission will try to work with member states and operators to develop guidelines on a minimum benefits package for every community where a CCS project will happen. So this should help communities and project developers, of course. Then we have actions for research and innovation and for cross-border cooperation. Now, on the CCS section, which is strongly correlated with NZIA, the ICM strategy plans to work on a CO2 demand aggregation platform, with this trying to solve one of the most important aspects on the value chain. Then the strategy proposes for the Commission to offer guidance to both member states and operators permitting, and this will be translated in the very soon publication of the guidance documents to the CCS directive. So most probably next month you will see them published. Mirroring this action, member states should support net zero strategic projects under NZIA and facilitate storage permits. And most importantly, the ICM strategy proposes the development of an investment atlas of CO2 storage sites and for member states to empower geological surveys into building this atlas. Let me tell you shortly what is behind this investment atlas. So, as mentioned before, the thinking of the obligation in NZIA is in obliging oil and gas companies in developing storage sites is that it is believed that they will be the first entrants on the market because they have both the knowledge and the money to do it. However, um, the business model for CO2 storage in an oil and gas company is always competing with the hydrocarbons business. And most probably it will not win in this fight because we all talk about profits. So the business model for CCS might actually be more attractive to other type of investors. With the organized in the right tool, data can actually be a good investment tool for other investors as well who do not have reservoir engineering or GNG departments in their companies, like oil and gas companies do. So, yeah. Mm, Before moving to the timeline of all this, it would be interesting to look also at the research and innovation part in the ICM strategy. Here, I would like to point out that the Commission will also support the development of a knowledge sharing platform, which will be populated with projects, ongoing projects, status of projects, data, and everything related to the not geological part of information in CCUS. Now, this is the timeline of what we are planning to do as announced in the regulations. So in June this year, NZIA will enter into force. And then at the end of 2024, as mentioned, member states will have to have in place regulations for the data release and transparency, and then they will start reporting annually on ongoing projects. And then in 2026, the ICM strategy mentions early 26, but this might not be achievable. We should have the investment atlas of potential CO2 storage sites, and then the knowledge sharing platform should also become available also in 2026. Now, before moving to now we will be moving in the second part of this discussion, which is what is the use of theoretical data mapping. And yeah, what we have now is the CO2 Stop Atlas, which some of you in the room probably have worked on. It is available since 10 years ago. It represents a collaboration between several geological surveys. What this atlas does is to map locations suitable for storage across 27 countries. In total, almost 1,000 storage locations were found, and the total theoretical capacity assessed by this CO2 Stop project in saline aquifers and hydrocarbon fields surpasses 500 gigatons. According to the final report of this project, the main purpose of theoretical mapping is to help policy makers by answering two questions. One, what is the theoretical storage capacity? And two, where is the most potential across Europe or in a certain country? Right now, and probably you know about this better than I do, there is the Geological Service for Europe project working on mapping the sustainable geoenergy capacity, which will result in a pan-European online atlas. Along with energy storage locations and geothermal energy mapping, we will also have an update and improvement of the data on CO2 storage locations. This will surely lead us to a better understanding of the theoretical storage capacity. From our understanding, data in this project will become available sometimes in the first part of next year. And then the atlas should be ready sometimes in 2027. Let's now overlap the planning with our policy planning. So if we look at this, right after the member states will release the data on potential storage sites, and right after they will oblige oil and gas companies to release their data, we will have the data from the Pan-European Atlas available. And then question to you is, what can actually be done on the span of 1 year, on 1 year and a half, to make all these data transform into an investment tool? So the question is, how can we move from theoretical capacity mapping to an actual investment tool? So as mentioned before, and I took this from the CO2 Stop final report, the main purpose of a theoretical storage atlas is to answer these two main questions. Where is the storage potential and what is the theoretical capacity? CO2 Stop identified more than 500 gigaton storage capacity for Europe. This number is huge. Before joining the commission, I used to work in oil and gas, and I worked in a company which was planning to develop storage sites. And I remember the CCS project manager in my company coming at me after looking at this atlas and saying, Anca, I don't understand how this mapping was done, because looking at our own assets and what actually seems to be suitable from the knowledge that we have, less than 10% that we can actually use. And actually, it's really important to have in mind, and I will read now an extract from the final report of the CO2 Stop project, which says that it is of utmost importance to be aware that the presence of a resource does not indicate that any fraction of it can be exploited economically now or in the future. In order to move from a resource estimate to a reserve estimate, a series of technical, legal, socio-economical criteria have to be applied to the resource. So I'm really glad that I participated in the discussion yesterday, and that everybody in this room is preoccupied into how to move closer from a resource estimate to an actual reserve estimate. And actually, this is what we want to do with the investment atlas of CO2 storage sites. We want to see how we can help you reduce constraints and actually apply additional criteria to the data so that we can move to a more realistic capacity estimate that can help all types of investors develop storage sites. So in the next part of my talk, I have analyzed shortly the constraints raised by the CO2 Stop final report, because I think that none of them has actually been overcome. How we think that through the recent policy initiatives, we managed to help reduce them, and then to think what else can be done. So this first slide will show constraints that we actually think we managed to reduce through our policy initiatives. First, there are the data-related constraints. The report mentions that there is lack of availability and different quality of existing data. That is true, but through the data release and transparency provisions in the Net Zero Industry Act, we think that we can overcome this constraint. Good. There is an additional step that needs to be taken, because the provision in NZIA, as you also mentioned, is quite general. And data availability can, of course, be a blessing, but if not done right, it can also be a curse. So here we need your help, because we plan to mandate the competent authorities on what type and format of data to actually release and require to oil and gas companies to release. This should be done sometimes before the end of this year, because the regulations that should stipulate this should be in place towards the end of this year. Then There are the so-called surface constraints, regulatory and socio-economical ones. We think that we can solve this through the obligation for member states to report on the development of capture sources, of transport capacities, and of CO2 storage projects on their territories. Also, the knowledge sharing platform will come with a lot of important information which can reduce the economic risks for projects by knowing where would be most where it would make sense to actually develop a storage site. And for this, we also need your help. Do you think that the conclusions of these reports can actually be transformed in criteria to be added to the data, to be applied to the data? Like, can we build layers to the pan-European atlas or to the investment atlas, which would show this? This would be, we think, very important for potential investors. And then we have technical constraints, which were also raised by the investment atlas. And for instance, there is additional work that could be funded. And I'm taking this also from the CO2 stop final report. So the report proposes for a methodology to estimate the dynamic capacity of aquifers should be made. So basically moving to the dynamic domain, as you all discussed yesterday. Then build cost models so that the cost of storage and injection could be better understood. All these methodologies could actually be part of a larger project that could be funded by the EU in order to better understand and make more realistic the storage capacity assessment. And then there would be a need for new data to be acquired. This is another constraint mentioned in the CO2 stop final report. Well, considering that hydrocarbons exploration activities have been downsizing lately, the novel world of CO2 storage can actually lead to an increase of seismic acquisition activity. So this should be seen as an opportunity. And to conclude my talk, um, we think that the investment atlas of CO2 storage sites should actually be a tool that, as mentioned, should help any kind of investor build storage sites. It should, and the wording in the industrial carbon management strategy says that this investment atlas should actually be built on the theoretical mapping done by the Geological Service for Europe project. This means moving from a theoretical field closer to a commercial one. As I mentioned a bit earlier, funding will become available at EU side for this to be developed. What we would like you to consider is that in order, the natural way to actually move from a theoretical field to a commercial one is to have collaboration between the research geological field and the commercial geological field. So all of you here in the room, if you could think how gaps could be filled through collaboration between research and commercial, this would be a great step forward. When funding will become available, it would be essential to already have a formed collaboration between the research and commercial fields, because in order to actually understand the investment needs, both knowledge and the business side should be put together. Thank you for bearing with me.